All right, and you should have a little pop-up to be presenter.
Yep, I see it. Let me just see. Go ahead. Yeah. Is my screen visible?
Yep, I see your remote desktop manager.
Perfect. Right, so good morning, everyone. Good afternoon. My name is Saurav Agarwal. I work as a program manager with the SQL Server Tiger Team, focusing mainly on the HADR technologies for in-market SQL Server releases. Prior to my stint as a program manager with the SQL Server Tiger Team, I was working with the Microsoft Services team, where I was providing consulting services to our enterprise customers. My focus during that time was mainly SQL Server and additional data technologies which are there from Microsoft, like SSAS, RS, IS, data technologies on Azure and things like that. Right. Today, as was earlier mentioned, we'll talk about some of the things we are doing with Always On in SQL 16, and then some new diagnostics or monitoring capabilities which we are adding to SQL 16 Always On. Right. And so overall, this is what we will cover today. We'll talk about some of the fundamental changes which were done to SQL Server 2016 Always On. Then we'll move on to some perf enhancements which were done to SQL Server 16 Always On. This is a combination of both the enhancements which were done in SQL 16 RTM and SP1. Then we'll talk about, or briefly talk about domain independent AGs, which in my opinion is a great addition to the capabilities of Always On availability groups. We'll talk about Always On direct seeding, which is again a great way to initialize your secondary databases. We'll talk about the database failover detection, and then we'll talk about tracking Always On latency. This is a new improvement we are driving with SQL 16, 14, and 12 Always On, and would be available sometime towards the end of this quarter or this semester. So yeah, without wasting any more time, let's go ahead and start with some of the fundamental changes which we did in SQL Server 2016. So with SQL Server 2016 and earlier versions of all SQL Server which had always on capabilities like SQL Server 2012 and SQL Server 2014, we got a lot of feedback from customers and people in the field, MVPs, around how to best utilize our secondary replicas. So with 2012, we used to have 4 replicas. Then we moved on with, or in 2014, we had 8 replicas, right? And most of these replicas could be configured as a readable secondary. Now, in order to configure this as a readable secondary, we create the read routing table wherein if let's say if a server A is primary, servers B, C, D, and so on can be the readable secondaries. Now, up to SQL 2014, what we used to do is all our read loads or all our read connections would go to the first secondary in the routing table, right? Or in the routing list. So for example, if my server A was primary and servers B, C, D, E were secondary, with server B mentioned first in the routing list, all my secondary connections or readable connections would go to my server B. And only if my server B was down, the connections would go to server C, right? In SQL 2016, we made a change with how our read loads get routed. So what we said is we give a option to create a read routing list such that the read loads across the secondaries could be load balanced, right? So if I were to pull up an example of how that works, let me pull up a notepad and just quickly talk about how the read routing or the load balancing works. So assume, let's say this is one of my read routing setup example. Let me just go ahead and increase the font on this so that just give me a minute, guys. Let me just increase the font on this. Yeah. So what we're doing here is if my SQL 16N1 is a primary replica, I am creating a routing list with two sets. The first set contains SQL 16N3 and second set contains SQL 16N2, while the second set contains SQL 16N1. Now, how it works is if both of my secondary replicas, that is SQL 16N3 and SQL 16N2, are available and are accepting connections, the first read connection or the connection which comes with read intent would go to SQL 16N3. The second one would go to SQL 16N2, followed by the third one to SQL 16N3 and the fourth one to SQL 16N2. So we have a round robin load balancing algorithms for the secondaries if they are up and available in the first set. If for some reason SQL 16N3 is not available, my connections get routed to SQL 16N2. All the connections will go to SQL 16N2. Now, if assuming that both of my secondaries are unavailable, my connection will get routed to SQL 16N1. Right? So, provided that both of my secondaries are available, SQL Server does a round robin load balancing across the secondaries to give you a better throughput across your secondaries or better read load balancing across your secondaries. And the more secondaries you have, the better load balancing you can achieve. So with SQL 16 you can have about 8 secondary replicas, all of which can be used as a readable secondary, right? Now, the other thing which we did change in SQL 16 was provide support for DTC. Now, this is an ongoing enhancements. We are doing a bit more on the SQL 17 side of it or the VNext side of it. So there will be more capabilities with respect to DTC and other operations which were previously not allowed, but as of now we do not have a full set of capabilities listed out, but there's a lot of work going on around it right now. Right. The third thing we obviously changed was with respect to group managed service account support for SQL Server Always On or SQL Server 2016 Always On availability groups. And then another key thing which we changed was, or we allowed to do, was have more than 2 failover targets, auto failover targets. So now you can have up to 3 auto failover targets, wherein if you have, let's say, 4 replicas for your always on availability group, wherein your, let's SQL 1 is, for example, SQL 1 is a primary, SQL 2, 3, and 4 are secondaries. You could have SQL 2 or SQL 3 as your synchronous replicas, and then configure automatic failover from SQL 1 to SQL 2 or SQL 1 to SQL 3, right? Now, how does that work behind the scenes when an actual failover needs to happen? And which failover partner or which failover target will SQL Server choose to bring the availability group online on? So that is controlled by the clustered preferred owners setting. So if you go to your clusters and go to your SQL Server availability group resources, the resource would have a preferred owners list. So this failover routing happens as per the failover preferred partner or preferred owners list. So if you have server 1 as the first entry in the preferred owner, which is typically would be your primary owner, and then you have server 2 and server 3, failover will always happen to server 2 first, provided server 2 is available. If server 2 is not available, failover will happen on server 3, right? So SQL Server decides based on the cluster preferred owners setting for doing the failover. We might, I have heard this question a lot, whether we should go ahead and change the failover partners or the preferred owners settings. Should we move it up and down? It is possible, you can do that. The cluster does not stop you from doing that. But the idea would be, or the best recommended practice would be to not play around it with a lot. I mean, play around a lot with it, because there might be some inherent or some unwanted consequences of playing around with the possible owners and the preferred owners on the cluster list. So try to keep it as simple as possible, and try to add the replicas in the order in which you would want to do the failover. So when I say that last part, when I say add replicas in the order in which you would want to failover, this is to do with your always on availability group setup. When you specify the replicas to add in the availability group creation wizard, that's what the cluster takes as an input for the preferred owners list. So if while creating my availability group, I go ahead and add replica 2 first and then replica 3, that's how my preferred owners list gets populated in the first place. And then, if required, we can always play around with the list, or how do we add the replicas to change how your failovers would happen. But anyways, the last thing which we did obviously is we enabled support for a basic availability group in standard edition. Now this is a single database availability group where your databases would be in a non-readable secondary format. This is more for a this is more from a DR perspective, and you have failover capabilities, but the failover capabilities are limited. Obviously there is good MSDN documentation around what are the capabilities associated with a basic availability group. I would recommend, if you are using standard editions and you want to use the availability group, the basic availability group, just go ahead and read the MSDN documentation. The slide deck, when I share it with the group, has links about the basic availability group and how do we go and configure those. Right. Perfect. Now, the other thing obviously we did with respect to always on in SQL 2016 was to make it much faster compared to what we had in 2014 or 2012. Right. This is obviously in response to the next generation class of hardware which we have in market today. Most of the hardware which our customers are using are really high end, and we wanted the always on availability group feature set to be, to cope up with the hardware speeds. Right. So we did a ton of improvements, and based on the improvements, what we were able to achieve is almost 95% of a standalone OLTP workload. So when I say 95% performance, what basically means is that if you have a standalone server without any synchronous replicas, you could achieve, let's say, X throughput on that server, right? Now, having a secondary replica obviously adds a little more overhead to it, especially if it's a synchronous replica. Now, with our testings in SQL Server 2016 and the improvements which were introduced in SQL Server 2016, we were able to introduce. Hey, Angela, could you go ahead and mute? Yep, thank you. So as I was saying, with SQL Server 2016, we did a lot of code changes, and the way we do redos, the way we do commits and everything. And based on the changes, or because of the changes, we were able to get very close to what you would see in terms of performance on a standalone environment. Now this is true for both always on availability groups with encrypted connections and without encrypted connections. So in the graph which you see on the screen, the blue line is what you would see when you have a standalone OLTP environment, right? On the y-axis, we have the log throughput, and on the x-axis, we have your number of concurrent users, right? The yellow line is the throughput or the always-on performance which you would observe on SQL 2012 or SQL 2014. The orange line is what you would see on SQL Server 2016 without encrypted connections or encrypted always-on availability groups, and the gray line is with encryption enabled, right? So the orange line is what we are we see as the 95% of the performance observed on a standalone environment, right? So what are these changes which we introduced in 2016 always on availability groups? We streamlined our log transport. That is, how do we send a log across or log blocks across to the secondaries? We introduced a lot of parallel workers based on NUMA node partitioning. So now we made use of the parallel redo threads. We made use of parallel log writers. We made use of parallel sends, right? Right. So these are some of the parallel operations which we did. And then we did a lot of code optimizations. So just to give you an example of the code optimization, in SQL 2014, right, in order to capture a log block and send it across to the secondary, we do almost about 15 to 16 context switches on the worker thread. We optimized that code in SQL 16 to almost about half of those context switches. So now we do only about 7 or 8 context switches, while doing that capture of the log block and sending it to the secondary. So because of that optimization, right, our time to send and the overall process runtime has reduced a lot, right? So, and based on these changes which we introduced, obviously we see a lot of improvement and a lot of performance benefits out of the always on 2016 availability groups, right? You can read more information on this on our blog. This is Bob Ward from my team had also blogged about this in the past as to how much changes we see or what is the percentage change we see with SQL Server 2016 always on availability group in terms of performance, right? The other thing which we did is enabled support for domain-less availability groups or domain-independent availability groups. So in SQL 2016, 2012 and or 2014, the requirement was that the nodes in your always on availability group cluster would have to be in the same domains, right? And then we had SQL or Windows Server 2016 come up, which said that you can form a cluster without the nodes in the single domain, or you can, form a cluster with nodes in multiple domain, or with multiple domains with no trust. And to top it all, you could form a cluster with a work group also, right? So when SQL Server or Windows Server 2016 released or came up with these features, we also worked on the SQL Server 16 side to enable support for most of these domain-less or domain-independent features. So you could now create always on availability groups across multiple nodes across multiple domains or across a work group, right? You could do it with PowerShell scripts, you could do it with T-SQL scripts, you could do it with SSMS, a lot of things, right? So there is a full feature set compatibility for T-SQL, PowerShell, SSMS for setting up availability groups with domains or nodes in multiple domains or nodes in work group, right? The fourth thing, this is probably one of the most important things we did in SQL Server 16 to help set up always on availability groups for very large databases. Now, for folks who have worked with always on availability groups in the past, one way or the way to set up a secondary replica or to initialize a secondary replica was to back up the primary, copy over the backup files to the secondary, or restore the and then restore the backups on the secondary in a no recovery mode, and then also apply the tail log of the backup or tail log backup and then restore it on the secondary, right? Now this obviously required a lot of time because if your database is big, consider about 1 terabyte, let's say as an example, depending on your disk and the network, if you're taking a remote backup or a backup on a shared network drive, you could take X amount of time to just do the backup, right? And then additional time to perform the restoration of that backup on the secondary server, and then perform the join of the availability groups, right? Now, what we did is, in order to reduce that time, we enabled something called a direct seeding mechanism, wherein you can take the backup, you do not need to take the backup of your primary database and restore it on the secondary. You could form an availability group, or you can form an availability group with something called a direct seeding enabled, wherein the VDI stream from the primary replica are captured and restored on the secondary replica on the fly. So thereby it reduces the overall time to configure or to create a always on secondary replica. I have a demo to which I'll show in a bit about how to go, create a always on secondary or always on availability group with direct seeding. Right. So before we go there, the key things obviously is that you don't need to initiate a full backup on the primary. Right. You don't need to have network shared paths for the backup, and it automatically creates the restores on the secondary. Right. By default, we do not compress the VDI stream, but you could use trace flag 9567 to compress the VDI stream. Now, as with any compression and decompression, usage of compression and decompression would need more CPU bandwidth, right? But it might give you some, cost saving on the network bandwidth side of it. And then on the backup restore process, you have obviously one worker reader per and writer per LAN. So with and since we had direct seeding enabled, we also created a couple of DMVs for automatic seeding to keep track of how your databases are seeding, or what is the state where till what point the seeding has happened, right? So let me go ahead and show you a quick demo on how to go about and perform that automatic seeding. So what I have over here is my Azure VMs. Oh, come on. Where I have a node, say Windows Node 1 and a node Windows Node 2. I will be using my Windows Node 2 as a primary replica for my automatic seeding. So let me just go ahead and open the files for that. Right, so the setup is very straightforward. You can use T-SQL to do that. So obviously these are some of the initial, I just want to make sure that I do not have my, okay, so it looks like I had it from my previous experiments or demos. So let me just go ahead and get rid of the database on the secondary side. Right, now, so I have some 4 or 5 terabytes of database, approximately about 4 gigabytes of database, which I'm going to use as an example for the direct seeding. Now, how do you go about creating this is very straightforward. We use our T-SQL mechanism wherein I'm specifying that my Windows Node 2 would be used as a primary replica and Windows Node 1 would be used as my secondary replica. The key thing to note here is the direct seeding mode, which I'm specifying as automatic, which basically enables my direct seeding mechanism or automatic seeding mechanism. And rest of the construct is pretty straightforward. You have your secondary role where I'm allowing connections to my secondary. This is my synchronous commit, right? So once I initiate this command, the second step I would have to do is to go back to my secondary server, which is, let me go ahead and change the connections over here. So I want my Windows Node 1, which is secondary server. Make sure that my database is not there. Right. And then additionally, I have ongoing transaction which I can use on my environment. So this is just an example of how my database could still be operational while always on does all my automatic seeding work. So let me go ahead and create my, sorry, let me see. Sorry, I need to change my database context to master. And I can go ahead and create my, so these commands, obviously, the first command is to make sure that my secondary is joined to my availability group. And the second one allows me to create the database on the secondary. So I'll go ahead and execute that. So now my always on direct seeding should be enabled. I can go ahead and track it on. So right now it's in the seeding state. It's creating the database. Let me see if I can go ahead and create some tests on that database. So there are some operations which I have started on my database, right? And all this while I didn't have to take a backup of the database and restore it on the secondary, right? So once my seeding completes, I should be able to query my database and see if, so right now it's in the catch-up state. It completed the seeding, initial seeding. Now it's in catching up on the transactions which are being performed on the primary server. So let's see if I can query that server and see if I get my transactions on the database. So yeah, my transactions are now catching up on the secondary also. So my secondary database is already available on the, on my secondary replica, and it's catching up with the primary replica. Right. So right now you see that the database state is synchronizing. It's still catching up on all the transactions which are happening on the primary. And once it has done catching up, the state would change to synchronized. And over here, when we go back and check the state of my seeding, you would notice that it is completed. So right now I have a fully functional synchronized database on the secondary environment or on the secondary replica, right? So really quick way of setting up my secondary database, and can be used for large databases where backup and restore can be time consuming, right? Perfect. So so that's one very good feature with SQL Server 16 which we can use. And the next one which we also enabled is direct database level health detection. So earlier what used to happen is in earlier versions of SQL Server where we had failover availability groups enabled, and we had a few databases added to the availability group. There was no way to track if something went wrong at the database level to ensure that the availability group was failed over to the secondary, right? So for example, if let's say one of the files or the transaction log file for the database is unavailable, right? Earlier we did not fail over the availability group just because the transaction log file of the database is not available, right? That was based on how we do the checks for the availability group failover. So in SQL 16 we enabled an option called database level failover detection. That option, if I go back to my demo environment, and go back to my availability groups. So what that option allows us to do is, if we go to the properties of this, there is a checkbox over here called database level health detection. Now this option is not enabled by default, and you would have to enable it either while setting up the always on availability group, manually check that option, or after as a post creation method to enable that checkbox, right? Once this option is enabled, if there is a database level problem, always on availability group will take that into consideration and perform a failover to a suitable secondary replica, right? Right now, this with SQL Server 16 SP1, this feature is a bit limited in terms of what are the conditions on which failover can happen. Typical things which or conditions in which a failover will happen is when your database is not online, that is, it has gone into a suspect mode, or one of the files are missing and things like that. In the next version or in the next release, we are trying to update some of this information or some of these checks which we perform to make the failover more robust, right? This is still under consideration. I do not have the details of what exactly are the changes we will introduce at this point, but there is some work going on this in this regard, right? So yeah, let's quickly see how this works, right? So right now I have a availability group which is online on my Windows Node 2 and has this database AdventureWorks 2014 DW. If you notice, my Windows Node 2 is primary, while my Windows Node 1 is secondary. And currently my state of the database availability group, or always on availability group, should be healthy. All the nodes are up and running, synchronized, right? So let me try and initiate some transactions on this environment. So I'm on my 22 Windows Node 2 server. I initiate. So if you notice my query, this is just a random while loop which does 1 less than 2. So this is a never ending or infinite loop where I'm doing some inserts into that particular table. And I've added a wait for delay for 1 second. So I'll wait for 1 second, do an insert, wait for 1 second, do an insert. Now, if you notice this, I have added an explicit begin tran commit, which will ensure that my transaction commits after every insert operation, right? So I have this up and running. My databases are all healthy. Let me just make sure that my database on the secondary side is also healthy. Right, so everything is healthy. Now what I'm going to do is, so for the purpose of this demo, what I had done is on my Windows Node 2 server, I had placed the log file in a separate BHD drive, which I can take offline if I need to. So the log file for this database AdventureWorks 2014 DW is on this drive over here, which sits on this VHD here. So I'm going to go take this VHD offline. So this is so what this is what I'm trying to show here is that your disk drive has gone offline and your log file is unavailable, right? So what happens if your log file is unavailable? You will not be able to commit the transactions, right? So if I go and see over here, I get the error message saying that my log file is not available, commit cannot happen, and obviously my database disconnected, right? Or my connection was terminated. Now let's see what has happened to my always on availability group in response to that error message. So if you notice, my always on availability group has now failed over and is now primary on the Windows Node 1 server, right? And you would obviously notice corresponding error messages in the SQL error logs and the cluster logs saying that the log file of the database was unavailable. We found the database in an unhealthy state, and that's why the failover is being triggered, right? So this obviously is a good way to ensure that for issues where your database is unavailable and your application is not working, always on availability groups responds to those types of events and does a proper failover to ensure that your uptime is not drastically affected, right? There are extended events to track this also, database failover. There are there are extensive error messages logged into the cluster log and the SQL Server error logs to indicate the problem in response to which my failover was initiated, right? So, and as I said, we are still enhancing some of these checks based on which my failover will be initiated. Right, so that's just a quick demo on how database level health detection works. Now, moving forward, this is something I want to quickly cover, which is, then this is a problem which I'm pretty sure all of the DBAs on the call or all of the administrators on the call would have seen or would have at least talked about in the past. So this has got to do with you have a synchronous replica, you have everything configured, you have a primary, you have a secondary or multiple secondaries for that matter, you have synchronous replicas, but for some reason your always on is not catching up. Your databases are either always in a synchronizing state or they are in a disconnected state or something, right? Or in other words, there is something keeping the databases from being synchronized state and thereby being in a truly HA mode, right? So we'll try and cover some of the enhancements or some of the changes we are introducing or we are going to introduce at later point in time this year to help detect some of those problems, right? So before we get on with the actual enhancements, just quick recap on how the data flow happens in SQL Server always on availability groups. So you have your primary replicas, you have your secondary replicas. On the primary replica, you capture your log block or your logs. You compress the log if it's SQL 2012 or 2014, or if it's a asynchronous replica for SQL Server 2016, right? Compression is disabled for, or compression is not used for SQL Server 2016 synchronous replicas, okay? And once my log block is ready to be sent across to the secondary, we put it on the transport layer where the network, takes care of sending the packet back to the secondary. Now, once the packet is received on the secondary server would decompress the log block if it's compressed, right? Then it would harden the log block, which basically means persisting those changes persisting that log block to the log file. And once the hardening is complete, it will send an acknowledgement back to the primary server, right? Now, as an asynchronous mechanism, on the secondary server, you would have your redo threads working, which will try and redo the transactions on the secondary side, right? Once the primary server receives the acknowledgement of the hardened LSN, we go ahead and commit the transaction on the primary side, right? So this is the overall mechanism, just a very high level overview of the mechanism which we use to send the log blocks to the secondary and then receive the acknowledgement and commit the transactions on the primary side. Now, if you read or if you look at this diagram, and try to figure out where are the potential or where my potential latencies can come from, right? There are few places where it can come from, right? One is obviously on the primary side. If the primary side is high on CPU, or there is a CPU contention on the primary side, you might have some added delay for compression of the log block, right? Or the encryption of the log block if encryption is being used, right? And then putting it on the secondary on the transport layer. Then the second thing which can come up as a latency is the network latency, wherein it takes time to send the packet from the primary to the secondary replica, right? The third latency can be on the secondary side, wherein again you could have a CPU issue, you could have a potential disk issue on the secondary, wherein it takes time to harden the logs in the log file, right? Then the round trip for the acknowledgement could be delayed because of a network latency, and eventually the commit on the primary side. The commit on the primary side should not be that big a problem. It is only a problem if any of the previous sections had a latency, right? So if you have these latencies, right, and you are noticing a delay in your transactions or in your replicas, right, how do you track this latency? What are the things you can do, or how do you figure out where is the potential latency, right? So a few things are at your disposal. Obviously, with SQL Server 2016 and 2016 SP1, we added a lot of new perf counters, extended events. We added some reports in Management Studio, which is what the new thing I'll talk about here. And then we have a Power BI dashboard, which is available as part of the SQL Server Tiger Team GitHub repository. You would have seen this on blogs on our blog site, the SQL Server Team blogs. Right, just search for SQL Server or Tiger Toolbox on GitHub. You should be able to retrieve the repository for latency tracking with Power BI. Right. As I was saying, with SQL Server 2016 and 2016 SP1, we did a lot of changes. We added new perf counters. We added a lot of new extended events, and using these extended events, we have created a very simplified way of tracking latency using SSMS. Now, this is a feature we are currently working on it. This is not currently full baked, and it is not available for consumption as of now. We are targeting a release sometime towards the end of this quarter or early next quarter. And once we have this available, this would be shipped as part of the SSMS vNext release. So you could go to the SSMS download page whenever this is available and download the new SSMS, and this would be available as part of that SSMS build, right? As I said, the timelines we are looking at is towards the end of this quarter or early next quarter, right? Now, what does this do, right? So what we have here is in the always on availability group dashboard, right? So let me go back to my demo machines here for a minute and talk about this. Right. So if I go back to and for this example, I use my always on availability group called SQL AG1. Now this has 3 replicas. One is all the 3 are synchronous replicas. The only difference is that the first 2 replicas, that is Windows 2 and Windows Note 1, are in the same data center, while the third replica is across the globe in Singapore. So there is some network latency there, right? Now, as part of the always on availability group dashboard, what we are doing is we have this option here called collect latency data. Now what this does is it creates a so when you click on this guy, it will create a SQL Server agent job on all the replicas, right? So this will create a job on the primary replica, this will create a SQL agent job on the secondary replica, and so on and so forth, right? Now what these replicas do is, or what these SQL agent job do is, they create a extended event session, then they run the extended event session for about 2 minutes. That's the threshold we have kept for the time being, right? We do that for 2 minutes, and then we spend some time in trying to extract that XEvent data into a table in your TempDB database. And once the data has been extracted, we go ahead and report it using Management Studio reports. So let me go ahead and pull up an example report. So actually, instead of pulling up an example report, let's go ahead and create some test setup for this. So what I have over here is a very simplified load pattern where I'm generating some insert load, I'm generating some read load on the secondaries, and I am generating some write update load on the primary, right? So I have an insert and update load on the primary, and I'm generating some read load on the secondaries also. If I just go ahead and show you the scripts for this, these are very straightforward scripts where I'm using SQL Stress to create multiple sessions to read data from the secondary server and then insert and update data on the primary server, right? So while those three are running, let me see if my job execution has completed. So this is currently executing. Right. Now, on a typical environment with a lot of operations, right, or an environment which has a very high number of transactions going through, it is possible that the execution of this job may take some time. The reason why it may take some time is because as a step to this job, we are doing the extraction of the XEvent data, which depending on the data we have captured, it may take some time to get that extraction completed. Now, where do we go ahead and log these data, or where do we store this data? This is stored in your SQL Server error log folder. And it is, let me just pull that up. So if I go back to my log folder, so this is the XEvent trace which we are running to capture the data. Right, so yeah. So we have this data set captured. I'm assuming my job would have completed by now. Hopefully, yep, it is done. And so this is done on secondary, primary. Let me just quickly make sure that it is completed on the secondaries also. Yep, it's completed on the secondary. So let me just, so now once my job has finished extracting data, what I can do is I can go to my always on availability group, go to a section called reports, and now we have added two standard reports. One is called your primary replica latency report, and the second one is called your secondary replica latency report. The primary replica latency report will only work on the primary replica, and the secondary replica report will only work on the secondary replica. Right. If you try to open the secondary replica on the primary replica, we will not, the report will open, but it will not show any data. Right, so let's go and see my primary report or primary replica report. So over here, I have my details of what is my configuration of the always on availability group, what is my primary server, what are my secondary servers. And then this is a graph wherein I'm recording my overall commit times for the primary replica. And there is a corresponding graph for my overall secondary replica remote hardened time also, right? And then as a second page to this report, we have a few numbers which give an overall view of what is happening on this always on availability group, right? So the first number over here is commit time, which is basically the overall commit time for the logged operations or the log blocks, right? Now, as I can see, this is about 232 milliseconds, and my corresponding remote hardened time, that is the time to apply the logs on the secondary, is about 228 milliseconds. So I can see that there is a potential problem with my remote hardening time, right? Now, the send time is about 2 milliseconds. Now, this send time is not the actual time for the entire network. This is the time we take to put the packets on the TCP/IP layer or the network layer, right? Then we are also giving some numbers for group commit, and since this is a secondary replicas in SQL Server 2016 SP1, we do not do compression by default, so there is obviously no data for compression, right? A similar statistics can be generated on the secondary servers, and this is where this becomes really interesting. So if I go back to my secondary environment and look at the report, so yeah, so these are my secondary statistics. It will only give me statistics for that particular server, that particular secondary. So I have some graphs which talks about the processing time for my remote hardening and replica send time and blah, blah, blah. The key thing here is the numbers again. If I go back to my second page. So here I see that my apply time, that is the actual hardening time on the secondary replica is 78 microseconds only, which is obviously very less, right? Now, if I were to compare the numbers on the primary replica report and the secondary replica report, I see that my remote hardening response says that it took me 228 milliseconds. But on my secondary side, it's saying that my apply time only took 78 milliseconds. Now, where is this time spent, right? So this time, I mean, right now I can say confidently that this time was spent on the network packet transfer, because if I go and let me go ahead and open my command prompt. And if I try and ping my secondary replica, right, from the primary replica, I get a network response time of about 222 milliseconds, right, which is basically the time I am spending to send a packet to the secondary and get a response back from the secondary, right? This is pretty much what is showing up on my primary replica time here. So here I can very clearly say that yes, this is a potential problem with network latency, not necessarily a problem with the secondary or primary itself, just a problem on the network between the primary and the secondary. So if I were to increase my network capacity between the secondaries or between the replicas, I would probably get a better commit time and remote hardening time for my always on availability group. Now, these, as I said in the beginning, these reports are not the final report yet. They are subjected to change. This is a work in progress. We aim to publish this sometime end of this quarter or beginning next quarter, but yeah, we will see as to when we are able to complete the work and put it out there. Right. So with that, I am sorry. With that, I am.
I hate to interrupt. We need to wind this down because we have a lot of questions for you.
Sure. So yeah, that's what I was coming to. I am towards the end of my session, and we can open for any questions we have.
Okay, excellent. Thank you so much. Our first question is AG in 2016 still not supported for replication?
When you say SQL 2016 replication, oh, so you mean replication along with always-on availability groups?
For databases participating in SQL transactional replication.
Yeah, I don't remember the top of my head. I'll just go and check that and revert back. But yeah, to the best of my to the best of what I remember, yes, we do not still support full replication capabilities with always on. I'll have to go and check completely. I don't remember at the top of my head. If Angela, if you if you could send me the email address of the participant who asked this question, I can follow up with them.
Okay, sure.
Yeah.
The next question is, how can we route the request to secondary replica when we use a linked server?
I am trying to understand the question. So could you repeat the question, or is there a way I can see the questions on the board? Because, sorry.
Let me see if I can get these over to you.
Yeah, sure. Because I was not sure about the link server part for always on, and the first part about the secondary. Was it about? Okay, I didn't get the question completely. So.
Okay. While I'm looking at how to send this to you,
Yep.
I'm going to repeat the question. How can we route the requests to secondary replica when we use a linked server?
Oh, so okay, so I think I get the question now. I think it's about you have. So let me see if I can understand the scenario here. So if you have a server, let's say A, where you have created a link server to another environment which is using an availability group, right? And as part of the link server, you are using, or link server name, you are using the always on listener name, right? And when you perform a link server query, by default, the connections would go to your primary server, right? And the question I'm assuming is to how do I route it to the link server? Sorry, to the secondary replica, right? Is that the correct understanding of the question?
I am. Just a moment. Let me see.
Yeah. Okay.
Yes, that's correct.
Okay. Perfect. So yeah, right now there is no straightforward way of doing that. There was a that is something which we are aware of, and there is some work going on with that respect. I am not at the liberty to talk about what exactly we are doing with respect to that, but there is just to make sure that we are on the right track. We are working on some changes to that aspect, wherein a link server to a always on availability group could potentially be routed to a secondary replica without any additional overhead. There is a outstanding work on that right now.
Yeah, and the next question is, how many databases can be included on one availability group on Azure LAAS SQL Server 2014 version?
For SQL Server IaaS, that is the infrastructure as a service, this is very similar to your box environment, so there should not be any restrictions on number of databases. There is an old Microsoft recommended practice, and that is something we are going to change in the future about having 10 databases per AG, but you can definitely go beyond that as long as you have enough CPU and memory on the machines. Because with each additional database in an AG, there would be additional thread requirements, and if you are running out of threads, you probably obviously will not be able to add more databases. So the bottom line is, if you have enough hardware to support the database, you could go ahead and add it to your AG. 2014 on an IaaS environment is no different from 2014 on a on-prem SQL Server or on-prem environment.
The next question, are system version temporal tables fully supported and always on? If a table is altered to enable system versioning while the system is running, do the changes automatically propagate?
They should, yeah, they should.
Okay.
Is there and I'm not sure if the question is coming from a behavior which was observed. If we have observed a behavior where the transactions are not being propagated, please reach out to me and I'll have a look at what is happening there. You could reach out to me on Twitter at SQL Server, or you could reach out to the Twitter handle of MS SQL Tiger Team, and we can definitely have a look at the behavior. But it should have the transactions propagated to the secondaries without any problem.
Excellent. We have a few more questions that I can answer. One of the questions is, is this being recorded and will it be available? And the answer is absolutely yes. The session is being recorded. It will be available on our YouTube channel. An email will go out in a few days to everyone, sending the link to the recording, and also once Saurabh gives us his PowerPoint, it will be available in the history page of today's session. And I'm looking to see if there are any more questions for you. We have a couple of minutes. During the AG direct seeding process, besides CPU network impact, is there any locking, blocking on the primary database?
There should not be any major locking, blocking on the primary database. It's just that the VDI does an initial snapshot of your database, which should be very, very minimal impact. It should not. So if you remember from my demo, I was doing a transaction on the database while my direct seeding was going on, right? And I was able to commit those transactions on the primary and as well as transition those or ship those to the secondary side. So there should not be any blocking as such.
Okay, great. Thank you so much. We have some people asking if the scripts will be available as well.
I can make those available. That should not be a problem.
Okay, fantastic. I want to thank everyone for coming today. Thank you so much, Saurabh, for giving us a presentation. We are out of time, and I wish everyone a fantastic week.
Perfect. Thank you, guys. Thank you, everyone. And thank you, Angela. Yep.
Thank you.
You guys have a good day. Bye-bye.